Hello, welcome to this lesson on our study of partial differential equation. So if you have not subscribed to my channel yet, kindly subscribe for more videos. Alright, so in our previous video we discussed about how to solve a PDE of first order in the form like this, where all the terms are present. Okay, now we have a typical example here to solve. Okay, now comparing this to our general PDE that we wrote the formula for, we said that the general form was AUX plus B UY plus CU equals some f of xy. So here we know that our A is equal to 1, our B is equal to 2, our C is equal to 2x minus y, and our f of xy is now equal to 2s squared plus 3x y minus 2y squared. Now in our previous discussion we said that to transform this to a normal ODE, we said you have to use the transformations tau is equal to ax plus by, which implies that this tau for this is a is what, 1. Okay, so let's not write the 1. X plus b is what, 2. So this is it. And we said our s is equal to bx minus ay, and this implies that our s is equal to b is 2, x minus a is 1. Have this, and he said our whole differential or PDE or partial differential equation will change to the form a squared plus b squared. Okay, but let's first solve for our x. Is that our x is equal to a tau plus bs over a squared plus b squared. This implies that our x here is equal to a is what, 1, our b is 2, so I have tau plus 2s over a squared is 1, b squared is 4, and I add them, I get 5. Okay, so this is my x, and I'll probably need my y. Okay, we said that y is also giving us b tau minus as. Okay, is it as? Yes, all over a squared plus b squared. Okay, so this implies that our y should be equal to simply 2 tau, let me change it, 2 tau minus s over 5. Okay, so now what is my f of xy and what is my c of xy? My c is equal to, in this question, is this. Okay, let me write it, let me show you too. This is my c. Okay, and you can see that this c is exactly the same as s. So here, in other words, if I want to transform c to, that is c of xy to s and tau, c is simply this s. Okay, let me show you, c is simply this. Okay, alright, so we can now transform our c to simply s. But what is our f of xy? Okay, we have a lot of work to do here. We said you have to transform our f of xy to f of s tau. Okay, now let's do this work here. Our f of xy, okay, our f of xy should be transformed to f of s tau, meaning wherever I see s in this equation, I put the expression for x, which is this, and wherever I see y, I put the expression for y, which is this, and transform them into s and tau. Okay, alright, let's see what we'll have here. Okay, now let me write my f of xy again. Okay, and we'll continue from there. It is 2s squared, okay, plus 3xy minus 2y squared. Okay, now with this we are being given x and y. Okay, that this is x, this is my y. So wherever I see x, I put the expression for x there. So it means that my f of s tau should be equal to 2 into brackets tau plus 2s all over 5. Okay, this whole expression here, okay, this whole expression here squared, then plus 3 times the two expressions, 2s over 5, then 2 tau minus s over 5. Okay, then minus 2 y is what? 2 tau minus s over 5. Now if you go through this carefully, of which I believe you can, okay, or should we go, let's go through it together very quickly. Okay, but to save time, let me write the answer for you. If you go through this carefully, you will expand everything. Okay, let me write the first expansion for you so that you'll be able to do it. Okay, so the top one will be tau plus 2s all squared over 25 for the first one, plus 3 into tau plus 2s, then 2 tau minus s all over 25. Okay, minus 2 into 2 tau minus s, okay, over 25. Okay, so the square is supposed to be here. So here you expand everything, and after expanding, this is where you're supposed to go, but you have to prove it yourself. It should give you s times tau. The whole of this expansion, some will cancel others. Expanding the top here in the first expression, this one you expand, then you expand this one as well, you expand this one, then you do your own cancellations. Some will cancel others. Okay, it's a tedious work, but you have to pass through that. And after everything, you're supposed to get f of s tau to be s times tau. Okay, all right, so let's see it here. Okay, we are saying that, okay, this is our x, this is our y, this is our c, this is our tau. Everything is now in place, and we are saying that f of s tau is now equal to s times tau. So let's put everything back together into this equation. Okay, this is the general equation we said you will use. Let me write it here. We said after everything, let me go and write it in the next slide. We said that after everything, the equation you use is this PDE will tend to a squared, okay, plus b squared u tau, then plus c of s tau, I mean c in terms of s and tau, then u equals f of s tau. And now we are saying that our a squared plus b squared is actually equal to 1 plus 4, which is 5, and our c of xy has turned towards s, and our f of s tau is now equal to s times tau. Okay, then the whole of the PDE that we are solving will change to 5 u tau plus c is being given su is equal to s tau. So now this becomes very, very simple. A simple ODE. You divide through by 5 and get u tau plus s over 5 u equals s tau. Now this is the first order ODE, where if you want to solve, what you have to do is find some integrating factor. Okay, and the integrating factor for this is given as this. You have your integrating factor. Let's say integrating factor, okay, to be equal to e to the power integral of whatever that is here, okay, with respect to the independent variable. So the independent variable in this simple ODE is just tau. Okay, this is just a simple function u, which we differentiated with only with respect to tau. Okay, with this function or this equation. So e to the power integral of the constant that is in front of u is s over 5 d tau, and this will give me e to the power s over 5 tau. Okay, now plus some constant, but then in the integrating factor formula or the theorem, the constant is 0. Okay, so you don't write it. Now after that, we said that you multiply your integrating factor through the whole of the ODE. Sorry, this has become an ODE, so you multiply it through the whole equation. Okay, so you get something like e to the power s over 5 then tau into u tau plus s over 5 u equals, then multiply it to this side as well, s over 5 tau then s tau. Rearranging, okay, the moment you multiply it through this, the next step is that you write something like this, d tau. Okay, so the independent variable, like we said, is tau. So what you do is, on the left hand side of the equation, always is like this. Once you're able to find your integrating factor, this is how it is. You just write d tau of the whole bracket u, okay, u times your integrating factor, which is s over 5 tau. Okay, s over 5 tau. Here s is a constant because you are doing everything with respect to tau. Then it should be equal to, okay, this should be equal to, sorry, with the equation here is supposed to be over 5. Okay, there is a mistake I made here. Okay, when you go to the top here, right, that is it. After dividing through by this 5, okay, let me see, after dividing through by this 5, you are supposed to divide every term in the equation by 5. So this side is supposed to be over 5. Okay, this side. All right, so make that correction and let's come here. Okay, so here is supposed to be over 5. Let me change the pen for you. All right, so here is over 5. Then here too will be s over 5 then tau e to the power s over 5 tau. Okay, let me change my s and 5 because it's as if they are the same. So s over 5 then tau, or as the power. Okay, now with this, what we do is you just try to say that this is d of u e to the power s over 5 tau should be equal to s over 5 tau e to the power s over 5 tau then all times d tau. So this becomes a separable ODE where we can integrate both sides. Okay, you're integrating the left side with respect to u e to the s over 5 tau, integrating this with respect to the tau. Okay, so when you integrate the left side, you get the same u e to the power s over 5 then tau should be equal to s over 5 here, this one is a constant. You get s over 5, then integral of tau e to the power s over 5 tau d tau. Okay, so let's go and do the integral of that and come and put it in. Okay, so I have integral of tau e to the power s over 5 tau. Now this is integration by parts, so I say u equals tau, and the u will give me what, 1. Then dv is equal to e to the power s over 5 tau, and v will give me, when I integrate this side, I'll get, mind you, this is s over 5. Okay, this side is s over 5. I'll get 5 over s e to the power s over 5 tau. Because you integrate this, it goes like you differentiate the power with respect to tau, you get s over 5, then you write the same e to the power s over 5, then divide by the differential of the power. Okay, when you divide by s over 5, you get, it's like 1 over s, my s and my 5, s over 5, and you get 5 over s. That's why I have 5 over s times that, rather. Okay, so with this whole integral, tau e to the s over 5 tau should be equal to u times v. Okay, so for the integration by part, we said it's uv minus integral of v du, and this will give me u is what, tau, v is what, 5 over s. So I have, let me write it, well, 5 tau over s, then e to the s over 5 tau, then minus integral of v is what, 5 over s e to the power s over 5 tau du, and u is what, 1, so you don't write, still with respect to tau. Now this will give me something like this: 5 tau over s e to the power s over 5 tau minus, then I have 5 over s, and I integrate e to the power s over 5 tau, I'll still get something like 5 over s e to the power the same s over 5 tau plus some constant c, and the constant, since we are integrating with respect to tau, we have a constant function, that is arbitrary function in terms of s. So this is the integral tau e to the power s over 5, this with respect to tau. Okay, so with respect to tau, this is what we have, the tau. So you go to our function, we can still go ahead and simplify this. Okay, go ahead and simplify, and we get something like this. This whole thing is equal to, we have 5 tau over s here. That means we have 5 over s in both, and we have some, you can get something like this: 5 over s, then tau e to the s, well, let me factor the e to the s out as well, and tau minus another 5 over s. Okay, then if you could see, I've factored 5 over x from this side, okay, and this side, and I'll be left with tau e to the power something, but I'm still factoring the e to the power something out, so I'll be left with the tau here, and here too I'll be left with only 5 over s here. Okay, I hope you can see what I've done, and it's very simple. Okay, if you can't see, you can go through it step by step, and this is e to the power s over 5 tau plus some f of s. Now you go back to our previous slide, and we put we put this in. Okay, we put this final answer for the integral that we've gotten here in. Okay, so let's go back to our slide. So we're supposed to multiply s over 5 to whatever integral that you have here. Okay, so we have this u e to the power s over 5 tau, then is equal to that. Okay, so let's go ahead and input it there. All right. Okay, so I have u, I'm coming, u e to the power s over 5 tau should be equal to, now we said there was a previous s over 5 here, if you remember, times the integral that you've gotten. Let's go and check. There was this 5s over 5 here times this integral. Okay, and so this integral gave us the whole of this. Okay, the integral gave us that. Okay, so I have 5 over s, then tau minus 5 over s again, then e to the s over 5 tau plus f of s. Okay, so this s over 5, when you multiply this 5 over s, okay, it will go. Alright, so what you do is, since this s over 5 is multiplying through, let me use a different pen, let's say the white pen. Okay, so that you get to see it clearly. Have u e to the power s over 5 tau should be equal to, now I multiply s over 5 throughout, and this term will be left with, if I multiply it by that, I will get tau minus 5 over s, okay, and e to the power s over 5 tau, and plus s over 5 times f of s. I'm coming to write something, but then let me first write this. Now you see that the whole of this is in terms of s. Okay, so it's still some function of arbitrary function of s that we don't know. So we can quickly write this whole thing, that if I have f of s and I multiply by s, I'll still have a function of s only. So I'll get something like capital F of s. Okay, let me put it that way. Now I divide through by e to the power s over 5 tau, and have u of s comma tau should be equal to tau minus 5 over s. Okay, when this is being divided by this, I'll get 1. Okay, so for that one we will go, and plus f of s divided by e to the power s over 5 tau, and I'll get something like e to the power minus s over 5 tau. Then this will give me times capital F of s. Okay, now this is what I have. Okay, this is my final answer, and we are coming to write the final answer in terms of x and y. Okay, now mind you, tau, let me write it with a different color. Tau was given us what? As plus b, and a is 1, so I have x plus 2y, and my s is given us 2s minus y, if I can recall clearly. Okay, so it means u of s comma y should be equal to tau, and tau is what? X plus 2y minus 5 over s, and that is 2x minus y, then plus f of s, so we have f of 2x minus y, then that times, okay, let me shift it for you so that you can see the actual answer. Okay, so know that it's f of 2x minus y times e to the power negative 1 over 5 times 2s squared, okay, plus 3xy. This is also very small, okay, this is very small for me, but after that is this e to the power something is multiplying only this side, okay. That's why I wanted to write it to attach you so that you don't get confused. 1 over 5 negative 1 over 5 times 2x squared plus 3xy minus 2y squared. Okay, so this is the solution to the PDE given. This is very tedious, but then if you understand the process, you can solve it. Okay, know how you got to this stage using the integrating factors and a whole lot. Okay, you know that this is a transformation, so the final answer I have to transform it back to my x and y. Okay, the side here that we have e to the power s over 5 tau is like negative 1 over 5. Okay, the power of e is this s tau. So when you multiply these two, you're going to get 2s squared plus 3xy minus 2y squared. That is the multiplication of these two. Okay,